In this video, we will talk about how to find the orthocenter of a triangle given the three vertices of the triangle. So let's say we have this triangle right here, and we're given the coordinates of the three vertices of the triangle, and we want to find the orthocenter. So the orthocenter is the intersection of the three altitudes of the triangle. Now, an altitude is the perpendicular distance from one vertex to the opposite side. So when we draw a line from, let's say, this vertex to this opposite side of the triangle, it will form a 90-degree angle. So that's one altitude. Another altitude would be maybe this line right here from this vertex to this side, which also forms a 90-degree angle. And then the last altitude would be from this vertex to this side, which also forms a 90-degree angle. So the place where these three lines intersect, that is our orthocenter. And just as a quick note, the altitude doesn't necessarily bisect the opposing side. It just forms a 90-degree angle with the opposing side. So to actually find the orthocenter of a triangle, we can use this three-step process right here, where we find the equation of one perpendicular line, or one altitude, then we find the equation of another perpendicular line, or another altitude, and then we just find the intersection between those two lines. So let's see how we could actually do that for this particular example. So let's just pick this side right here. And let's find out what the equation of the perpendicular line is to this line. So first we need to find what is the slope of this line. So the way that we do that is, given these two coordinates, the formula to find the slope would be y2 minus y1 over x2 minus x1. So that would be, let's call this y2 and this would be y1. So we'll say 6 minus 3 divided by x2 minus x1, so 4 minus 7. So we get 6 minus 3 is 3, 4 minus 7 is negative 3, so 3 divided by negative 3 is negative 1. So the slope of this line right here is negative 1, but remember we want to find the equation of the perpendicular line right here. So the perpendicular line is going to have a slope that is the inverse reciprocal of this line. So if this one is, let's write it as negative 1 over 1, the reciprocal means you flip the numerator and the denominator. So in this case, it would still just be a 1 over a 1. But we take the inverse, which means we have to flip the sign. So instead of a negative 1, we'll get a positive 1. So we'll say the perpendicular line, this line right here, has a slope of positive 1. And to find the equation of that perpendicular line, we need to use the formula y equals mx plus b, where m is the slope that we just found is 1. And for x and y, we can plug in the xy values of a point that lies on that line. So we see that this 1, 2, this lies on this perpendicular line. So we can plug in a 2 for y and a 1 for x, and we'll solve for b. So let's do that. We get 2 is equal to, we said m is 1. For x, we're plugging in a 1 as well, plus b. So we get 2 is equal to 1 times 1 is just 1, plus b. If we subtract a 1 from both sides, we can see that b is equal to 1. So the equation of this perpendicular line right here is going to be y equals x plus 1. So this is our first perpendicular line. So we just completed step 1. So I'll make a little room over here. Okay, so here's our first perpendicular line. Now we just have to pick one of the other two sides of the triangle. So it doesn't matter which side we pick. So let's just say we pick this side right here. Let's find the slope of this line, and then we'll find what this perpendicular line is. So to find the slope of this line, we use that same formula where we said y2 minus y1 over x2 minus x1. So if we call 6 our y2 value and we call this one our y1 value, we get 6 minus 2 over, we'll say this is our x2 value and this is our x1 value. So 4 minus 1. So we get 6 minus 2, that's 4, over 4 minus 1 is 3. So the slope of this line right here is 4/3. So the slope of the perpendicular line will be the inverse reciprocal of this, which would be negative 3/4. So remember the trick that we can use again to solve for the y equals mx plus b equation. The m is our negative 3/4 that we just found. And for x and y, we can plug in the xy coordinates of a point that lies on this line. So that would be these xy coordinates. So here's what we can say. We can plug in a 3 for y, so we'll say 3 is equal to m we just found is negative 3/4. And for x, we'll plug in a 7. And then we have plus b. So we're trying to solve for b. So we have 3 is equal to negative 3 times 7, that's negative 21 over 4 plus b. Now we're going to want to add this negative 21 over 4 to each side. If we rewrite 3 as a fraction with 4 as the denominator, then that would be 12 over 4. So if we say 12 over 4 plus 21 over 4 is equal to b, 12 plus 21, that's 33. So we get 33 over 4 is equal to b. So kind of ugly, but that's okay. So our final perpendicular equation is going to be y equals, we said the slope is negative 3/4 x plus 33 over 4. So this is our second perpendicular equation. So I'll make a little room here again. All right, so we found the equation of two perpendicular lines. Now the last step is we need to find the intersection between these lines, because that will be the orthocenter. So to do that, we simply set these two equations equal to each other, and then we solve for x. And once we do that, we'll be able to figure out what y is. So we can say x plus 1, so this first equation right here, is equal to this second equation. So negative 3/4 x plus 33 over 4. So we need to solve for x. So one thing that we could do is multiply every single term by 4 to get rid of these ugly 4's in the denominator. So if we multiply everything over here by 4, we get 4x plus 4 is equal to, when we multiply this by 4, so if we were multiplying that by 4, these 4's would cancel out, and we'd just be left with negative 3x. And then when we multiply this term by 4, again, these 4's will cancel out, and we'll just have plus 33. So if we subtract a 4 from each side, and then if we add a 3x to each side, we will have 4x plus 3x is 7x is equal to 33 minus 4, that is 29. To solve for x, we can divide by 7, and we get x is equal to 29 over 7. Now that we've solved for x, we can plug in this x value into either one of these two equations and solve for y. So it looks like it's going to be much easier to use this first equation, so let's do that. So I'll make a little room right here again. Okay, so we said x is equal to 29 over 7, so let's plug that into this equation and solve for y. So we get y is equal to 29 over 7 plus 1. Instead of writing 1, we can write 7 over 7, which is the same as 1, and it has the same denominator here. So 29 plus 7, that is 36. So we get y is equal to 36 over 7. So these are the x and y coordinates of our orthocenter. So we could write our final answer as, I'll just abbreviate it as O. O is equal to 29 over 7, comma 36 over 7. Now, if you were to punch these into a calculator, the decimal equivalent would be about 4.143 and 5.143. So these are the xy coordinates of the orthocenter. So we can see, just based off this rough graph, that 4.1 and 5.1 would be somewhere right around here, which is indeed the orthocenter. So that is the three-step process that you can use to find the orthocenter of a triangle if you're given the three vertices.